I'm going to walk through some MCA practice problems here. Feel free to follow along, make any notes where you see that they're needed. Number 1, in 1977, there were 12,168,450 U.S. households with cable television. In 1997, there were 65,929,420 U.S. households with cable television. Over that time period, what was the average rate of change per year in households with cable television? The hint here is the average rate of change. When you see average rate of change, they're asking you for the slope. So right off the bat, I'm thinking slope is y2 minus y1 over x2 minus x1, where you have the change in y over the change in the x's. Now here's what's key is you got to understand, go back and look, say, well, where are the coordinates? Here are your coordinates. In 1997, there were 12,168,450. Think of that as one coordinate. Then your second coordinate is 1997 and 65,929,420. That's your second coordinate. Now we just need to fill these in. Well, your first numbers are your x's, your second numbers are your y's, and you just need to decide which one's your first set of data and which one's your second set of data and stay consistent. My first set of data will be the 1997. I'm going to start with that, but it's the y's over the x's. So let's start with the 65,929,420 minus the second y coordinate, which is the 12,168,450, divided by, now I need to go in the same order. Since I did 65 million minus 12 million for the y's, I need to do 1997 minus 1977 for the x's, just to stay in consistent order. Minus 1977. Now, when you go to do this on your calculator, I would highly suggest that you go through and do the top part first, and then do the bottom part. So the top part gives us, after you subtract them, 53,760,970 divided by 20, which is 1997 minus 1977. So this number went here, this one went here. Do that on your calculator now, and what you find is that your answer ends up being, or matching up with A. The answer is 2,688,048.5. Big thing here that's coming into play is the fact that you are working with the slope. Let's move on to the second problem in our practice. It says, please fill in the grid with your answer to the question number 2 on page 2 of your answer book. In your answer book, you'll get a gridded response question. This is a gridded response. I can go, once I find my answer, I put my answer inside these spaces and I bubble them in. Harrison High School has 768 students in 6 years. It is projected to have 1,157 students. What is the projected average rate of change? Whoa, there's that average rate of change again, so we're dealing with slope. Per year in students over this time period. Round your answer to the nearest student. This is important as well. Listen to what they're asking you to do. Round it to the nearest student. In other words, no decimals. Well, where are our coordinates then? Well, we started at year 0 with 768 students. 6 years later, it went to 1157 is what they're projecting. So I'm going to put my second coordinate as 6 years, 1157. Well, again, here's your x, y, here's your x, y. Let's walk through a slope. Slope, or average rate of change, are your changes in y over your changes in x. I'm going to stay consistent. I'm going to go 768 minus 1157 on top. So 768 minus 1157 divided by the 0 minus 6. I need to stay consistent. I'm doing left minus right. So now I'm going to do 0 minus 6. And in that scenario, I'm going to get negative 389. Do the top part first on your calculator. Divided by 0 minus 6, which is a negative 6, which gives us 64.83. Now they said round to the nearest students, so let's round it to be 65. When we go to put that answer key in our gridded response, what we need to do is pick an area to write it. I'm going to write it in the last two boxes, so 6, 5, and then go down and bubble in the 6, and then bubble in the 5, and there's your answer. Now, sometimes they have where you have different answers. What they've done here is there are 4 different possibilities for answers. Notice how they've lined them up. Sometimes it's different. Here's the way I did it. You might have gone on the left-hand side, but you still bubble below it. You might have gone somewhere in the middle, and that's fine. The computer will figure that out, and the computer will figure out this way. So in other words, you can do any one of these 4 ways, and your answers will still come up okay on the answer key. Again, for this one, it was slope or rate of change. Let's move on to question number 3. A rabbit population grew in the following pattern: 2, 4, 8, 16, blah, blah, blah. If all the rabbits live and the pattern continues, how many rabbits will be in the 8th generation? What I like to do is I like to write out the numbers again. 2, 4, 8, 16. There's 4 generations, and they want 8th generation, so 5, 6, 7, 8. 8 generations. And then what I do is I say, all right, well, how do they go from one number to the next? And there's a couple different ways you can do it. You can say, well, 2 times what? Oh, 2 times 2 is 4. Does that stay consistent? 4 times 2 is 8. Times 2 is 16. I can continue on with that since I see a pattern developing here and say times 2 is 32. Then take that number times 2, and that's 64. And take that number times 2, and that's 128. Take that number times 2 one more time to fill in my 8th generation, and I get 256, which means my answer is C. Now, the other way that you might catch on is say, well, everything kind of gets multiplied by 2, so we're talking about 2 to the 1st, which is 2, 2 to the 2nd, which is 4, 2 to the 3rd, which is 8, 2 to the 4th, which is 16th, 2 to the 5, which is 32, 2 to the 6, 2 to the 7, and 2 to the 8th generation. 2 to the 8th generation is 256, which gives you your answer again. It's question number 3. In this case, you're looking for a pattern, and in a lot of cases, it's easier just to draw out the numbers and see if you can develop a pattern and fill in these numbers. All right, let's walk through example number 4 of the MCA. Pedro throws a ball upward at a rate of 20 meters per second from an initial height of 2 meters. The height of the ball above the ground can be approximated by h equals negative 5t squared plus 20t plus 2. Where t represents the amount of time in seconds since the ball has been released. What is the maximum height that the ball reaches? Let's think through this real quick and see what we've got going on. First thing I want to notice is that we're dealing with height is equal to, and then we've got a quadratic. So we got something that's going to be some type of parabola. And they want the maximum height. In other words, my parabola is probably going to open something similar to this. And they're asking for this maximum height that's reaching. And that makes sense since this is a negative 5t squared, then you're right. It's going to be opening downward, and I'm looking for that maximum height. Easiest way to do this is go back to our graphing calculator and use our graphing calculator to help us find the maximum. So let's bring our graphing calculator up. And what I would suggest you do is follow along. Let's get everything set. First thing I would do is go to second zoom, and I would actually just hit zoom, sorry. Hit zoom and then number 6, which is standard. And that just makes it back to a 10 by 10 grid, or -10 to the -10, your standard grid. Then I would go to second y equals, and I would hit number 4, which is plots off. In other words, I'm going to turn all these plots off so we don't have any interruption with that. So I'm going to hit number 4. It says plots off, just hit enter and it'll say done. The other thing I would do is go to y equals and clear out everything that you have in these categories here. Now I have nothing there, but you hit clear and I would go all the way down, make sure that it's all cleared out. Now we're ready. Let's type the equation in. So I'm going to type in minus, not minus here, but a negative, 5, and instead of t, we're using the variable x. And then you have squared plus 20x plus 2. There's my equation. Great. Let's graph it, see what we can find out, see if we can anticipate where the maximum might be. Oh, bummer. When I go to graph it, I don't see the maximum. It's off the chart. The maximum's up here somewhere. So it'd be really nice if I could zoom in. You can play with the zoom feature, or we can go right to our window and change our window. Now in this scenario, we don't care about the negatives and the positives. So what I'm interested in, and back to this scenario, what I'm interested in is this quadrant right here, quadrant 1, which is positives in both directions, from 0 to maybe, let's just say maybe 10, I'm not sure, and from 0 to, I don't know, let's say 25, since my maximum choice is 22 according to them. It's one of these 4 choices, but 22 is one of my highest. So I'm just going to say 25. So let's go back to our calculator, and let's change our x min to be 0. Our x max, let's let it be 10. X scale means what increments you want. We want increments of 1. Our y min, again, can be 0, because I don't care about anything in quadrant 3 or 4. And our max is going to be, let's go down to max. Let's just say 25, because I know it's got to be less than that, because I don't have any choices that are over the 25 according to my data here that they're asking about. Now I hit graph. Let's see what happens. Oh, nice. Now I can see the maximum point of our graph. So let's go through and figure out how do we find the point. What is that point? You can hit trace and go through and try and anticipate where it is. I think it's easier to do second trace, which is calculate. What are we interested in? If you go through this list, probably pretty easy to know that we're interested in number 4, which is our maximum. Again, that was second trace or calc. Number 4 is what I'm interested in, the maximum. And it asks for these questions. Left bound, question mark. What they want is give me a point on this graph that's to the left. If I were to draw a line straight down through the middle. Left bound means give me a point that's somewhere on the left side of the axis. Right bound will mean give me some point that's on the right side of that axis. So if I go back to a drawing, draw in this kind of scenario. This part right here is left bound, and anything right here, this would be right bound. So let's go back to our calculator and see where that will get us. So left bound, I need to go back to this, and I'm going to go ahead and hit left, because right now I see I'm at x equals 5, y is negative 23. So at 5, which is right here, I'm way down here somewhere. So I need to scroll left to start bringing it up. So I'm just going to hit this a few times. You can watch this numbers right here change. 4.2 to negative 3.4. Now we're at negative 1. Now we're at 1. Now you can start to see it coming into play here. There it is. And you can always watch these numbers to see where you should be going. I want to go left bound, so I got to get over to this side of this parabola. So I'm going to keep hitting left. Keep hitting left till I get to a point. It doesn't really matter where. It's good enough. We're to the left side of that center line. I hit enter. Then it'll say right bound. I'll say okay. So I go over to the right. Now I need to draw a line that's to the right of this middle line right here. And I hit right a couple times. Good enough. I hit enter.
Notice when you hit enter, it puts a little triangle here and a little triangle here. Now it's saying guess, and you'll say yes. It's going to take into account the equation and the points between these two triangles to determine what that maximum point is. So I hit enter, and it comes up and says your maximum is at 2, and the height of that is at 22. All right, so my maximum is 2, 22. So what's my maximum height the ball reaches? If I go back to this, maximum height is this part right here, and that is going to be D, the 22 meters, because on my calculator, here's my 22 sitting right here. That's my answer out of these choices, and that gets you through number 4. Now in this case, a graphing calculator is your best friend to try and work through one of these types of problems.
Number 5, which graph shows a function? A function. And if they give you the graphs, that's a nice thing. What they are asking you to do is, does it pass the, what we call, vertical line test? If I can draw a vertical line and I ever hit more than one point, then we do not have a function. So let's just go through and do that. Let's try this first one. A, if I draw a vertical line anywhere, I draw one here, I hit it only once. I draw it here, I hit it only once. If I draw it down the middle, I hit it twice. That's not good. That means it is not a function. Let's go down to this one. No matter where I hit it, it seems like I can never hit it more than once. So that's a possibility. Now don't just stop there. Read all your answers in case you catch something. Let's look at this one. If I draw a line here for part C, yes, it only hits it once. But if I go a little bit to the right, ooh, there it is. 1, 2. Hits it more than once, so it is not a function. Same thing with this one. It's hard to see in this case, but in this case we've got, and I'm going to draw these in because it's hard to see. Did not do a nice job of seeing it on the digital here, but it does something like this. It's what we call a step function. They are going up basically in steps. If I go back and draw a vertical line, I don't hit it more than once, I don't hit it more than once, but if I draw right here, look at that. I hit it more than once. Once here and once here. So again, this is not going to pass the vertical line test, so it is not a function. That leaves me with this one as yes. B is my best answer. It covers the vertical line test.
That should get you through questions 1 through 5 of the MCA practice test.